Hello and welcome everyone to today's coding challenge. Today we are going to discuss a question on Geek for Geeks. The question is vertical sum. In this we have given a binary tree having n nodes and we have to find the vertical sum of nodes that are in the same vertical line. Return all sums through different vertical lines starting from the leftmost vertical line to the rightmost vertical line. Okay, so let us look at the example number one. We have this binary tree. In this, the root node is at 0th level and all the other nodes that follow this vertical line, that means this 5 and 6, are inside this 0th level, and this is -1 vertical line and this is -2. So we have to return for -2. We only have one node, so the sum of all nodes that lie inside this -2 vertical line is 4. Then -1 single node, we have to return 2. Then in 0 we have 3 nodes, 1, 6 and 5, so we have to return 12. Then for 1 we have to return 3. Then for 2 we have to return 7. And let us look at this example number 2. If we have a skew balanced tree, then this root node is at 0th level. This is -1, -2, -3, -4, -5. So at -5 there is single node, that means 7, then 6, then 4, 3, 2 and 1. So the answer is 7, 6, 4, 3, 2 and 1. And the constraints are n is less than equals to 10 to the power 4. Okay, let us visualize our code first, then we will write a code and then we will visualize that. Okay, let's suppose this is our binary tree, and in binary tree let's make some vertical lines. This line, this is at 0th level. Okay, this is 0 and this is -1, then this is -2. This node is at -2. Then we have another node at 1 positive. Then we have another node at 2. So how to write a logic? It looks like that this is some kind of level order traversal but with some different logic. Let's suppose we try to find the level order of this. So at 0th level, this is 0th level, this is level 0, this is level 1, this is level 2. Similarly, as we store levels in our queue, let's suppose we make a queue. Let's erase this first. Okay, let's erase this. Let's suppose we make our queue like this. This is our queue. This is our queue that stores some information, and the information is looks like a pair. Let's suppose this is our pair, and in pair we have two values. The first value is the node, and then the second value is a vertical distance integer value. Okay, then we will traverse over this binary tree like level order traversal, and will give every node its vertical distance. Let's suppose initially we insert this root node into our queue. Then we can run a loop. To find out whether our queue is empty or not. That means this loop will run until our queue is empty or not. Okay, so for this root node our queue is not empty, that means make our queue as empty, that means pop out this. So this is our root node, this is our root node. For root node this is root, and that vertical distance is 0. Okay, then we will run an inner loop for I is equals to 0 till the current size of n cube, and current size is 1 before popping out this. Then we will check that whether for this root its left exists. Yes, for this root node its left exists, so let's put that into our queue. This is root dot left, but with distance, the current distance, that means uh, this minus 1 for left. And similarly we can check for this current root node that whether its right exists or not. Yes, its right also exists, so put that as well into our queue. This is root dot right, but this time the distance is not minus 1, the distance is plus 1 actually, distance plus 1, that means this is at minus 1, this is at minus 2. Again this loop will again check whether our queue is still empty or not. No, our queue still contains this left and this right, so let's again find out the current size of queue, that means the current size is 2. Let's run a loop and one by one pop out the elements. So the first pop out element is this. Okay, then this will check whether its left exists. Okay, yes, if it exists then push that into our queue. Left dot root dot left means for this, and the distance is distance minus 1, and then pop out the current right element and then check for the right element. Yes, right element also exists. Okay, so the right element is also exists, so put that as well into our queue, this time with distance plus 1. Okay, that means for this 2 its left is this and its right is this. Now its work is over. Then again this right comes, that means this 3, pop out this 3 and this will push its left and its right into the queue again, that means 6 and 7. So now we have 4 elements in our queue. The other element is root dot left. First element is root dot left with distance minus 1, and this is root distance plus 1. Let's increase the size of queue. Now for third level we have 4 elements. Yes, we have 4 elements. One by one pop out them and check for their children's. Null null nothing, null null nothing, null null nothing, null null nothing. So all the 4 values will be popped out from our queue and our queue is empty. But the main logic in our this level order traversal is whenever we pop out our root element, means a node, then we have to make sure that we assign we save its value in a hash map. Let's suppose this is our hash map. Okay, initially it contains nothing, so for very first node, that means for this root node, the vertical distance is 0, so we can insert some values inside it. That means for this vertical 0, vertical key, vertical distance as key, assign the value of every node, and if another node comes for this vertical distance, then add the value into this like this 1 5 6. Then for minus 1 it will be 2 only, because no more nodes for minus 1. Similarly for minus 2 it will be 4 only. Similarly for 1 it will be 3 only, and then for 2 it will be 7 only, like this. Then for 1 we have 1 for 1 3, and then we have 2, and for 2 the only node is 7. Now our answer should be in from -2 to 2, that means in sorted order. That means we can use either a sorted hash map, so that the keys appear like this: -2 first, then -1, then 0, then 1, then 2. Okay, let's write a code and then we will visualize first. Okay, let's create a array list in Java. This is a Java code. New array list. Let's check if our root given to us in question is null, that means no elements. Then we can simply return an empty array list. Otherwise we have to do something. Okay, first thing we have to make a sorted map. Then we can make a tree map, integer of integer, map tree map. Then second thing is we have to make a queue that takes two values, and for those two values the values are like this: node and integer. So we have to make another class as well, class pair. In that the first thing is node, and then the second thing is distance. Node distance node, and then we have to initialize distance as well. Okay, let's give this queue as a object pair. Okay, now we have to first push this root node root with vertical distance 0. Queue structure is like this. This will take a root, means a node, then the vertical distance. This is vertical distance. So for root the vertical distance is 0, and the tree map structure is like this. It will take for vertical distance as key. It stores the sum of all nodes lying at that vertical distance. Okay, then we have to run a loop while this queue is not empty. Okay, until it's not empty, please first find the current size of queue. This is the current size of queue. Then run a loop for I0 till I less than n. Okay, then for in that loop first fetch the element. That means node is what? Q dot peak dot node, and the distance is this, Q dot peak distance. Then pull out the current node. Okay, then for this vertical distance make changes in your map, or just save the current value of node, and if another node comes at that vertical same distance, then add that value into the previous value. That means use this syntax: map dot put for this distance. First check if this is the first value or not. That means distance, if distance is coming for the very first time, that means give 0 default value and assign node dot the data, that means the current value. Otherwise fetch the previous value for this particular vertical distance and add the current node value into that. Okay, now check if this node left not equals to null. That means if this node has a left value or not, left children. If it is if it has, that means push a pair of node dot left, but this time the distance is the current distance. That means for root node the current distance is 0, and for its left children the distance is vertical distance is distance minus 1, that means 0 minus 1 minus 1. Okay, also check if node dot right not equals to null or not. Okay, that means add a new pair, this time node dot right, and the current distance is the current distance plus 1. Okay, after that, after this while loop is over, just run a loop for values map dot values. This map dot values will return a view of all the values associated, and then you can add them into your array list, and then you can simply return your array list, your final array list. Let's first run this and check if it is passing. Yes, it is passing. Let's submit this. Yeah, it's pass all the test cases. So this is our code to find the vertical sum, and if you want another code in Python, then we can write a code in Python as well. Okay, in Python we first will check if our root is empty or not. If it is empty, then we can simply return a empty list. Otherwise let's make a answer list. Let's not make an answer list, we need to make a dictionary first. So let's initialize a dictionary. D is equals to default dict integer. Okay, we need to import that as well from collections, import dq and default dict. Okay, then we have to make a queue as well. Q is equals to dq and dq is root 0, that means, and then we run a loop while q, then find the current size of q, and then we will run a loop for the current size, and then we will fetch the node and the current distance q dot pop left. Then we will make changes in our dictionary, that means map, and we will check if d dot get this current distance is 0, then assign node dot data, otherwise the default value as 0 plus node dot data. Okay, then we will check if node dot left exists, then q dot append node dot left, and distance is distance minus 1. Okay, if node dot right exists, that means q dot append node dot right with distance plus 1. Okay, then finally we have to return a array list that contains all the values but in sorted form. and the sorted form is d of k for k in sorted d. This will return all the values. Yes, let's submit this. Yeah, it is also passing all the test cases. So this is the code in Python as well. Okay, and with this we'll end this video, and if you find this video helpful, then please like and subscribe to our YouTube channel, and thank you so much guys.